Okay, Jim, today we're going to talk about what causes the northern lights.
Oh.
Do you know about this?
I don't know what causes them, and I've never seen them, but I was watching something just the other day that talked about the northern lights, not like about them
I bet I know why.
in detail or whatever, but it just was mentioned in the show or something.
Oh, okay.
And I was like, I just was thinking like, those are really weird.
Yes, they are really weird and they're really cool. And we're actually right now in the middle of a geomagnetic storm, which I don't even know if we know what that means, but we're going to talk about it.
Okay.
And that's impacting our atmosphere, and it is likely to cause the northern lights right now. Probably not by the time this comes out, but definitely when we're recording. And I figured we were just talking about the solar eclipse, and now this geomagnetic storm is happening, and let's talk about the sun and the cool lights some more.
Okay. Sounds good. Let's do it.
All right, let's get into it. Hey, I'm Melissa.
I'm Jam.
And I'm a chemist.
And I'm not.
And welcome to Chemistry for Your Life.
The podcast helps you understand the chemistry of your everyday life.
Okay, and before we even get started, I do need to shout out Abby H., who asked for this back in 2021.
Ooh, nice.
So if you asked me a question, 2 years ago and I haven't gotten to it yet, maybe, take a little bit of hope.
I'm impressed that you're able to find that because it is so hard for us to go find some questions of old.
Yes,
sometimes.
It was actually in a text message. It was in some of our very early days.
Yeah.
And she's a friend IRL.
Right.
That texted about it.
Right.
Or sometimes I would text myself the messages that people suggested. I'd be like, oh, someone in real life just asked me a question. This would be a great episode idea.
Yes.
So, okay, so that is the first person who asked me about it. But it's been coming up more and more lately because of this geomagnetic storm.
Mm-hmm.
And I guess I clicked on some solar eclipse articles. So then my Google was like, what about other solar articles? And so it all came back together.
Nice.
Okay.
Nice.
So I actually think it makes the most sense to start our lesson today at the Northern Lights. In Canada. Let's go. No, at the Northern Lights themselves, and then we'll talk about what causes them a little bit later. So when I mean at the Northern Lights, I mean at the molecular level of the Northern Lights. So we're going to zoom in to the molecules, and we're actually going to go all the way back into just a basic refresher on like what an atom even is.
Okay.
So molecules are made up of two or more atoms, and atoms, they have usually a center surrounded by some particles. The particles we're going to talk about today are electrons. Okay, so we're going all the way back that far back. Okay. We've talked about it several times, but I just feel like it's worth it to do a little refresher.
Yes.
And so atoms surrounded by electrons, and atoms can absorb energy from heat or light. We've talked about that a lot. And therefore, they let the electrons surrounding the atom, those will sort of take in the energy for the atom. Is a good way to think about it. But something that we haven't talked about a lot is that we have talked about it a little. The episode that came to my mind was when we talked about how thermoses work.
Oh, yeah.
And how molecules or particles really of any kind will run into each other. They'll collide, and that will transfer energy.
Right.
So we don't talk about that a ton, but that is an important thing that transfers energy and then impacts the electrons. And I tried to think of a good analogy, and the thing I thought of was, imagine, so you have kids. You have let's say your son is hanging out just at a normal at-home state, And then one of our friends brings their kid over and say that kid is so excited that he's going to get to see his friend. And when he gets to your house, he's really excited. And then what happens to your son?
Also gets excited.
Gets really excited. And now they're just like,
wah! Yeah.
Literally, I've heard both of the kids I'm thinking of right now make that exact noise.
Yeah.
Okay, yes. So we'll say they went from their resting state or their ground state to their excited state, right?
Okay. Yes.
And before they can come back down to their ground state, in order to do that, you have to let them let off energy, right? Okay. And then, or another example I thought of is maybe like if you're at work and you're really stressed at work and you're taking in all these things that need to be thought about or worried about, and you're
Mhm.
just getting more and more stressed, you need an outlet a lot of times to like let that energy off. So like I used to go to kickboxing,
Right.
or you go running.
Right.
So that's like your way to come down from your excited state back to your ground state. Okay.
Mhm.
So electrons do the same thing. They start out in a resting state in a cloud around an atom.
Okay.
And then as they absorb energy, they'll move away from the atom into excited states.
Okay.
And you can sort of think of them as like concentric rings, or like sort of like rungs on a circular ladder or something, where they're concentrated around the middle of the atom. And then they're not super concentrated, I guess. They've got room to move, but they get further and further away into like higher and higher excited states.
Okay.
And there can be a variety of levels of excited states. And so they'll stay in that excited state for a period of time, and then they do something to let off energy to come back down to their ground state.
Okay.
And when I say for a period of time, this is like a very short period of time, like fractions of nanoseconds.
Okay.
Like very, very short. But that's a very basic primer on how electrons can absorb energy, and then they will come back down from the excited state to the ground state after they've let the energy back off.
Okay.
Okay, and oftentimes they let that energy off instead of like your son running around screaming, or me doing kickboxing, or you running. They let their energy out in a variety of ways, but one that we see is light.
Mm-hmm.
And something we know about light is that different wavelengths or different amounts of energy will result in different colors of light. Okay, so different atoms are able to absorb different amounts of energy. So I'm going to start with just talking about oxygen as an example.
Okay.
So oxygen, has a few different levels of, excited states that it can get to. So it will absorb energy in certain amounts that will take it from the ground state to maybe level 1, level 2, level 3 excited state. Okay. Just sort of speaking generally. And then when the electrons need to come back down from that excited state into the ground state, they will let off that exact amount of energy, which often corresponds to a color of light.
Mm.
It's light energy in a specific wavelength and a specific energy level. So, for example, oxygen very often will absorb enough light or enough energy and re-emit in the color green.
Okay.
Or if it maybe takes a little bit of a lower energy particle, it can take less energy in, and then it'll release that out and it'll look red.
Okay.
So these different amounts of energy that the oxygen is taking in and then releasing back out as it relaxes back down to its ground state, they correspond to colored light.
Okay.
Okay. And higher energy moves more towards like the violet spectrum, the green, and then lower energy is more like on the red side,
Right.
Oranges, yellows, oranges, and reds are lower energy.
Mm.
So, oxygen can absorb in these specific energy packets, is what they're sometimes referred to as, like a photon, a little packet.
Okay.
Photon is a packet of light, kind of. So they'll absorb a specific packet of light and then let that specific packet of light back off.
Okay.
Okay. And then it has these characteristic ways that it can do that. So it sort of has what we would call, it's like almost like a fingerprint called an emission spectrum, where if you were to shine light on oxygen, it will consistently emit the same colors.
Mm.
So I'm going to show you the emission spectrum, and I don't know if this is possible. I wondered while I was talking about or thinking about this, if I point up to the top of the screen on YouTube, would you be able to cut in a picture of what I'm talking about?
Oh yeah.
Okay, great. Okay, so right here, imagine. I guess you don't have to imagine. Hopefully it'll be there.
Yeah.
Is it hard to do that, or
No,
is it easy?
I could do it.
Okay,
Yeah.
great. Okay, so let me pull up the emission spectrum of just oxygen. Okay, and I'll link this also in our show notes, and Jam will put it in for us. But Okay, so here is a variety of different emission spectrums for different gases. But see how oxygen lets out maybe like a very little in the violet and then several in the green and then some in the red and orange, right? Or then if you have something like nitrogen, do we have the nitrogen one? Or like here's helium. Helium has a different spectrum. And so each of these emission spectrums are slightly different. And so they're almost like little fingerprints. Like, oh, if we see this emitting these specific lights at these specific wavelengths, these colors, we know that must be oxygen.
I see. Okay. That's
So
really cool.
we did this, and you may have done it too, because I did it in my Gen Chem class. So anyone who's taken like high school chemistry may have gotten like, they almost look like those little solar glasses. And they're so that you can kind of see the light broken out of the rainbow, and then you shine light onto like a tube of oxygen or a tube of helium, like in a sealed glass tube of it, and they'll like let the light out, and you look through that little thing, and you can see the emission spectrum.
Yeah.
And there's like a lot of different ways scientists use this, specifically with stuff in space, to see like what gases are in space and things like that. I don't fully understand that, but. And so there's all different types of emission and absorption spectrum. So here's a few more if you want to look. I like this one, the nitrogen. You can see it has more pink, like purpley blues, and then less in the red and green, while oxygen has more in the green and red.
Interesting. Yeah.
Okay. So we've never talked about that part of it before, the emission spectrum.
Yeah, that's crazy.
Yeah.
It's weird because I feel like, we talked about various different elements on the periodic table and that they behave differently. So it's like, that's not new.
Yeah.
We've talked about that a lot. But the fact that they behave differently in the ways that they emit light when they're releasing energy.
Yeah.
It's like, it feels weird at first because it's such an area that most of us haven't thought of.
Yeah.
But then it's like, well, I guess it's not that weird that like, we know that like iron has very different properties.
Right.
From,
Yeah.
oxygen or carbon or something like that. It's like
all that has to do with their electrons too.
And we know that because we've interacted with them.
Mm-hmm.
And the lights thing is something that we've probably witnessed, we just haven't thought about it.
Yeah.
But and like, who's gonna shine a light specifically like oxygen and look at that?
Yeah, you'd have to be in a science class for this to come up.
Right.
Unless you are
in Canada
looking at the northern lights.
Yeah.
So all that to say is what we see when we see the oftentimes green, because oxygen is the predominant thing that this is happening to, but sometimes blues and pinks and reds of the northern lights is energy being absorbed by oxygen atoms, nitrogen atoms, helium, hydrogen, energy being absorbed by those different atoms. The electrons becoming excited, and then as they relax back down to the ground state and let that energy back off, they do so in these beautiful displays of color. Because it's not just happening to one molecule, it's tons of them.
Right.
So that's what the northern lights are.
Okay. So we talked about what they are, and now you're going to explain why they're even getting energy excited, and why is it up there only? Is that good? Right.
Yes.
Okay.
That we are going to talk about both of those things. And I will say, so it kind of is cool. It's kind of like you're seeing the little fingerprints of all the different,
Yeah.
I think
it's
I was very
like,
excited
it's
about this.
almost like painting with all the colors of the wind, but like, different. You know what I mean?
Different. Yeah.
It's almost like instead of painting all the colors of the wind, you're sort of like lighting with all the colors of the elements.
Oxygen. Yeah. Yes, exactly. I love that. Okay. So, and for those of you who are listening and not on our YouTube channel, you can go check out our YouTube channel to see the emission spectrums, or you can just Google oxygen emission spectrum versus nitrogen or something like that. You can see the different ones. Or hydrogen. Hydrogen's pretty simple as well. It has less light that comes out in different areas. Okay, so now then, that's what's happening when the northern lights happen at the molecular level right there. But the question you asked is like, why though? Where is this energy coming from? Why isn't it all the time?
Right.
Okay, and that's where the sun comes in.
Okay.
And the geomagnetic storm.
Okay.
Okay, so The sun will sometimes, and I am not a solar physicist, so I don't know why the sun is doing this. And I probably could have looked it up, but that was beyond the scope of this episode.
Right.
Sometimes I the best way that I've like thought about it so far, solar scientists hit me up, is sometimes the sun will almost like spasm and it'll send out like more energy than normal. So you've heard of maybe solar flares?
Yes, I have.
Yes.
And I'm a sci-fi nerd, so like I've seen like that be a plot device of a certain
Depictions
thing.
of that.
Yeah.
Yeah. So sometimes very large or than normal amounts of energy get emitted from the sun, like an unusually large amount. That's why I think of it like suddenly a spasm happens and, whatever. And that will send charged particles going very rapidly towards the earth. Okay. But we have a magnetic field around the earth.
Right.
And that magnetic field, for the most part will deflect that. So think about like charged particles coming at a charged band of electrons are going to mostly, bounce away.
Mm-hmm.
But some of them will ride the wave of the electromagnetic of the, magnetic field around the earth.
Uh-huh.
And so like if you imagine there's like a nice little circular thing blocking out the earth, some of them will ride that wave and come close to the earth's atmosphere in a nice little crown sort of at the top of the earth. So if you look up the magnetic field around the earth, it's not a perfect sphere.
Mm-hmm.
But because of the shape of it, the northern lights happen where the magnetic field kind of comes in closer to the Earth's atmosphere, which happens to be not exactly on each of the poles, but like near the top of the and the bottom of the Earth. Like it makes a little circle, And so northern Canada is made up of that. Made up of that. Is present in that circle.
Got it.
Now I'm going to also pull up the magnetic field around the Earth, and maybe you can also put that right here.
Okay.
That would be amazing. Okay, so here's the picture of the magnetic field, and you can see that like it might not be exactly just on the Earth's. It wouldn't go just to the poles. It might come right here, like around the top and around the bottom. Okay, so because of that, sometimes, and lots of these charged particles will hitch a ride on the wave of the shape of the magnetic field, and they will collide with the oxygen, nitrogen, what have you, atoms in the atmosphere or on the outer edges right there. And that is where the beautiful displays happen.
Got it. And these don't happen on the South Pole because they go... Oh, do they?
I think they do. So we talk about them being the northern lights, but I think they happen on both ends, but it's just that the northern side has land that we can get to more easily.
Right. I was thinking that you were going to say something about like the polarity of that magnetic field means that the direction they go is toward the north, something like that.
I don't think so. Let me double check.
So you're telling me there's northern lights and there's southern lights too.
Lights.
I didn't realize there were southern lights. I did not know that.
Yes, in the northern hemisphere, it's called the aurora borealis or the northern lights. In the southern hemisphere, it's called an aurora australis. Australis? Or the southern lights.
Got it.
So apparently, they happen both places.
Wow.
Interesting.
Now that's crazy.
Yes.
It's weird how they don't get much. I mean, like what you're saying makes total sense. We can obviously go to one of those much more easily, but it's just funny that like that never even heard that until now that there is a Southern Lights. Wow.
Well, why would you? Nobody sees it.
Yep.
Well, I guess not nobody. Not very many people hang out down there.
Yeah.
Yeah.
Yeah, it's crazy. There's this sci-fi show that I love that I think you would like. That even we talked about this actually. That I think at some point in the podcast that both my wife and my mother-in-law also like. We've all watched. It's hard to find a show we all like. It's called For All Mankind.
Yes.
Alternate space race history thing.
Yes. We have talked about this.
In one of the seasons, there is a solar storm kind of thing, and there's people on the moon, and the moon is much more exposed, and so that energy, that radiation, that kind of stuff was a big deal in that episode about what they do to be safe, stuff like that. And also, the effect it has on the moon is interesting, and I'll I think it's accurate to like what we think might happen.
Okay.
Like I don't know if it's ever been observed on the moon.
Mm-hmm.
But I'll show you a video afterward of how they did that. But it looks really cool. Now I'm kind of seeing a connection between like the weird ethereal oddness of the northern lights and the way that they tried to render an effect on the moon. Anyway, but I'll show you later. But it's from that same thing. I didn't really realize that it was the solar flare deal.
Mm-hmm.
Okay, wow.
So, and I don't know if I ever specifically said that a geomagnetic storm is when those shooting charged particles are coming towards the Earth and they disturb the magnetic field around the Earth.
Mm-hmm.
That's called a geomagnetic storm. And then I also learned all about like solar weather, which, is basically the concept that solar flares happen and then they can impact our magnetic field, and that's a storm. And so it's called like weather.
It's crazy because the sun's like so far away.
It does.
It messes with us, like, and also we need it. So.
And there was a very crazy thing. I'm not trying to fearmonger or turn everybody into preppers, but because of a geomagnetic storm in the 1980s, I think, like some parts of Canada lost power for, it was something crazy, like 9 hours.
What?
And, at that point, I feel like in the 80s, that wasn't a big deal. But if it was probably a big deal, but not as big of a deal. Like right now, if we all lost power for 9 hours, I feel like it would be chaos.
Right. Yeah. People would be definitely freaking out.
Yes.
Yep.
Anyway, that was just something I read. I read it really late at night. Sometimes I get into researching these things and like I do it too late. So now this is not in any of our sources and I haven't revisited that. It was just a weird thing that I saw, but one more thing for us to be scared about.
Yeah. That's so funny because I feel like a lot of us would be like, wait, look for a radio or, something like that. Like, it'd be like, what?
Who can I call?
Yeah. We don't have any power. And if the power also got knocked out to the cell towers or something like that, it'd be like, how do we get information?
How do you communicate? I know. I think we'd all just have to stop.
Yeah.
And maybe it'd be chaos. I don't know.
I bet people they start walking around in the street and be like looking for somebody who knows what they're talking about. Like a bunch of us just like leave our houses for once.
Yeah.
Or whatever and be like, do you know what's going on?
I was like, I'm glad I have a bunch of neighbors within walking distance so I could at least talk to somebody. And we would all just not know what to do together.
Mm-hmm. I mean, I'm glad that my neighbor like grows food and like has chickens and like has eggs. The power goes out longer than I'm be knocking on his door like, you're self-sufficient. Can we make some sort of trade here?
That kind of plays into what my happy thing for this week is. But let's stop our little tangent here.
Okay.
And do you want to try to explain this back to me? And then we can go into our happy thing.
Yes, I would love to. So the elements, the oxygen, the nitrogen, the hydrogen, the helium.
Yep.
They just want to shine. They just want to. They just want to show. They just want to show us who they are, and we just won't let them. Most of the time.
Or we just don't have the energy to let them, maybe.
Yeah, right. There we go. We don't have the energy to let them in the large scale sense.
Yeah.
But you know who has a lot of energy?
The sun?
The sun. My son really likes this like classic folk song, Mr. Sun, Mr. Sun, Mr. Golden Sun, please shine down on me. One of the lines in that.
I've never heard that.
Oh, you haven't?
No.
One of the lines in that is these little children are asking you. It's something about sun, Mr. Golden Sun hiding behind a tree at one point.
Yeah.
And as I've listened to this song hundreds of times at this point, I've realized like it's behind a tree. So like all you gotta do is like move. It's like it's behind a cloud where like there's nothing we can do about it. So like if the sun's behind a tree, that's because you are behind the
You're
tree.
in the wrong spot. Yeah.
Anyway, Mr. Sun has a lot of energy.
Yes.
And sometimes Mr. Sun sends a lot of energy. More than we're used to toward the earth very rapidly. And our magnetic field pattern thing is for the most part kind of prevents that from really getting into our atmosphere, getting into a way where it could visually affect. It probably still affects weather and stuff like that, but in a visual sense where most of us live. But the pattern works to where at the poles, it can get much closer. And so that energy can actually raise the energy level of these electrons.
It's like it sends electrons with energy shooting, and they go interact. They knock and collide and transfer energy.
So they are electrons fast.
There's also protons, but those aren't the ones that are doing most of the work.
Got it. They're just hanging.
I think so. I was like, well, what happens to the protons? No answer.
Yeah. That's so funny. They're like we're not like, what happens to protons? And it's just like crickets.
Yeah, that's how it felt when I was searching for it. And I was like, well, okay.
Yeah. So they are colliding and transferring energy, getting the other ones excited. Like the kid who finds the other kid, the buddies, they get each other excited.
Yep.
And as they get excited, there's different levels to that excitement the electrons have that are the concentric rings around the protons, the nucleus, the whatever. But then as it's coming back down from that excited state, which that's always hard because that feels counterintuitive to me for some reason. Going down, that's when it's emitting light. And based on what level of excitement coming down from affects which color.
Yep.
Also which element.
Yes.
It was that electrons got excited in the first place.
Yeah.
Both what element and how excited.
Right. Yeah.
And all those things happening to work at the right time in those conditions, that situation can suddenly make a lot of electrons become excited and come back down. And so it's visually a lot of light being emitted.
Yes, from a lot of different oxygens or nitrogens or whatever. Yep.
And different energy levels, I guess. So different colors plus the elements. And then it's this crazy, beautiful, awesome thing.
There you go.
And it's real.
It's real. I was trying to think while you were talking about like what's a good way to describe that. And then something I thought is like, what if we had a bunch of different soda machines and they took in like only like this one only takes $1 and this one only takes 50 cents or $1.50 and this one only takes in 25 cents or 75 cents or something like that. And so you can go to different soda machines and put in different amounts of money, and each one will only take different amounts of money, and each one gives you a different soda.
Yeah. Okay.
It's sort of like that. Like oxygen will only give you these certain colors, and it'll only accept these certain amounts of light. And nitrogen will only accept these certain amounts of of energy, and it'll only give off these certain colors of light. You know, it's like each separate atom has a separate amount of energy it will absorb, and in return, as that energy gets released, it will only give off, you know, one of these specific colors. So it depends on, both the identity of the atom and the amount of energy that it happens to absorb. But it can only absorb certain amounts.
Okay.
So, which is very counterintuitive.
Yeah.
Because it should just be like, oh, we put some energy in it, we get some energy out, and we can put in any type of energy, and that exact same type of energy will come out or whatever. But it's not like that. Someone described it to me once as like photons of light have a specific wavelength, and it can't give off anything more than that. It's not like it can give off half of its energy and like the electron hang out between the ground state and the excited state. That's not possible. Just like how a soda machine can't dispense half a Coke.
Got it.
So.
Got it. Yes, I see.
Yeah. Great. Well, good job.
Well, good job to you too.
Thanks. Can you tell we're tired? Do you want to talk about, or maybe I'll talk about my fun thing since it transitions well from what you're talking about.
Yes,
okay.
Totally.
Well, lately I think I've just been thinking a lot about like all the suffering happening in the world. And like, so I think some of it is like social media just, brings you the sad things. But there's been a lot about like the war going on, and then there's like a lot of other things I'm learning about other exploitative practices that are really putting a lot of people's lives in pretty miserable conditions as a direct result of just like our economy and the way things are set up. And it's been making me really sad, which doesn't sound like a happy thing because it's not.
Yeah, I think you're misunderstanding the assignment.
But then I think I've spent so much time thinking about that and then kind of like feeling helpless because it's like, well, my representatives aren't doing what I want them to do. And I don't even know if the thing that I want them to do is really going to like help anything.
Right.
And so like, what do you do? Because these are like huge issues. And then I thought there are some like practical things that we can do in general, stuff that you and I talk about before, like reduce your waste and try to make things last, whatever. But something that I've been thinking about more lately is like a really tangible thing that I can do to make life better overall for the people around me is to just, you know, love the people around me well.
Yes.
And try to just like do something nice for them. And I don't know, it feels so small, but just like helping someone nearby you who needs it is a tangible thing that you can do to make the world better.
Yes. Even
if it's just like a small scale and like, even if it feels like this isn't going to make a huge difference. And also like I can learn about things, even if that doesn't feel like it's making a huge difference.
Yeah.
But so that's something that I guess I've just been thinking about is like, it is important to learn about these big, hard things. But whenever I get too overwhelmed by these big, hard things or feel like lost in it or feel just like overwhelmed with despair about it and like how I feel helpless, I can help a human being like watch my friend's kids or bring someone a meal or invite a friend over to cook a meal for them. Or, you know, I got this little sign in my yard that says, you should turn off your lights in DFW because there's a bird migration happening and the birds might hit your window and die. And if you turn off your lights after a certain time of night, you're like much less likely to let birds die. It's like these small things that can help or like I've started composting. I don't know. It helps more when I'm like thinking of a specific person, but
yeah,
that I think like building community and loving the people around me well and trying to help them has been the thing that I've been clinging to lately. And it's bringing me a lot of hope and joy, even in the face of like so much despair and sadness. And so, yeah, that's just something I was just thinking about.
That's good. That'll preach. I'm very down with that. It is huge because it's like, it doesn't fix the things we out there, but it is something that does affect the place where I'm at right now.
Yeah.
And that, you know, we all wish, and I think really deep down everybody does wish they could have a much broader impact than that.
Yeah.
But if we're so hopeless about the fact that it's hard to do that we don't do something small here, then none of us are going to do anything, you know? But it's like if a bunch of individuals did small things, actually that would be huge, right?
Yeah.
So I love that. That's really cool.
Yeah. And even just talking, like there's a few of my friends that I hadn't really talked about like that I was feeling this way about with anyone really. I guess I was just kind of like holding it inside me, except maybe Mason, but you should always have more friends than just your spouse. And, you know, so I just felt like I was kind of like alone worrying about all this stuff and feeling really sad. And then I just talked to a few of my friends and having community in that and knowing that you're with other people who feel the same way and like trying to think about things that you can do together, that helped too. And then they told me that they've also found other community that's been doing that's been pouring back into them. And then so I don't know. That's been an encouraging thing in the midst of all of that. So yeah, that's been my happy thing. There's been like a few specific instances that I'm like, I made this person's life better today.
Yeah.
You know?
Yeah. That's cool.
Or they made my life better today.
Yes.
Because you have to be, I saw a TikTok that was like, if you don't let people help you, that's anti-community. If you're helping other people all the time and you're not letting people help you and you really need it, you're being anti-community and you're part of the problem. And I was like, ooh, yeah.
Yeah.
But there have been some tangible times people have made my life better too.
Yeah.
So
yeah.
That's just been a big picture thing I've been thinking about.
Very cool. I like that a lot. That's awesome. I totally had mine, and it's gone.
Was it while I was talking or before that?
No, I had it before, and I remember thinking you going first made more sense, and I wasn't worried about it. And then slowly mine has gone, and I'm just trying to figure out what it was.
We can do that thing, that sometimes people will do when they show like the time has gone by. Is that like little colorful screen and it's like boop.
Yeah, exactly.
And then
bars and tone.
And we'll cut this part out and just let the bars and tone happen.
Okay. All right, perfect.
I think you should leave the part where we're explaining that in because that would be funny. Yeah. You had it while I was talking. I feel bad.
No, it's okay. I even had it before we.
See, I wrote.
Before God had been thinking. Oh, got it. I got it. I totally got it.
Got it. He's got it. All right.
Okay. So I got it.
Okay.
It's just like one of those things where it's like, it's a happy thing, but I guess, in a perfect world, maybe I would wait a week or two in the next recording and tell you more about how it's actually going. Maybe I will still do that. Mm-hmm. But I'm excited about it. So I'm going to tell you about it right now.
Yeah, just tell me about it.
So I had been many, many times, and I mean many, many times, considering making this decision, and I haven't done it. Because I've put it off, or I've thought, I don't know if I need it right now.
I have no idea what this is going to be.
And it's going to be underwhelming. But so finally, I feel like the need is there enough, and so I'm going to do a sort of trial, 2 months of working at the co-working space in our town.
Oh my gosh. With our friend Ryan.
Yep, our good buddy Ryan.
You just doxed yourself, so now everybody can come find you while you're at work. Anybody who's listening to this podcast.
That's true. I think we've done that many times though. Like we talked about like the coffee stand we walked to, and I think we shouted it out by name. But you got to be a member to come there, so people would. They can't just find me. Actually, it's better to be there than to be at a coffee shop where anyone can walk in.
That's probably true.
Anyway, co-working space, may or may not remove the name that I said a couple seconds ago. We'll see. But for a few reasons. One, my house is kind of crazy, and I have this, probably anyone, you included, especially like you've been in the working remotely for like a long time at this point. And even before that, you would work around different places and stuff like that if you needed to. Yeah. But the difficulty of like, if you work at a coffee shop, you got to pay for something. Like I want to support the coffee shops here, obviously. Yep. I don't want to just use this space. Adds up. I also have coffee at my own house that I have already roasted. Yeah. That I like a lot. Yeah. If I stay here, free coffee or sort of free. But my house is kind of chaos. And sometimes, it's hard for your kids to be like, okay, Dad's in the other room, and there's all these windows actually into this office. Yeah,
they have like French doors that you can see through. Yeah.
So it's just kind of challenging, and I think there's a point in the future where I wouldn't need to have a different place. But I kept thinking, really, really nice to have a comfortable chair, desk to have things spread out, good internet outlet, and free coffee. They have free coffee, so you're paying for the place, but you get the coffee. Yeah. What I'm doing at other places, I'm paying for the coffee, and I'm getting the place for free. So to speak. So I'm gonna.
Is it good coffee?
Yes, it is. It's not good with an E at the end.
It's not your company's coffee, but it's still pretty good coffee.
Yes, it's pretty good.
Great.
Yep. And so I'm gonna try that for a bit. I'm pumped about it.
That's something so exciting.
Fun about a new environment to work in a little bit, and I'm not like sitting at a desk working tons of hours every single week, but there are chunks of time, multiple days of the week, sometimes, maybe every day of the week, that I need to have a place to go get a bunch of things done, but it's a very fixed amount of time that I have. And so having it be somewhere kind of around town that I'm already going to be bouncing around doing other stuff is perfect.
Amazing.
So I'm pumped about it.
That's really fun. Sometimes I've had that same problem.
Mm-hmm.
Mason and I negotiated a small budget for me to be able to go. When I got a raise, I was like, I am putting in a request now for you in our budget to take some of that raise and let me go hang out at coffee shops. But lately it's been like, they like kind of hurt my back or whatever. Or like I'm, having my blood sugar issues. So I need to eat something that's like pretty good for me. And like a lot of that stuff's not. So sometimes I'll just pretend that my coffee table or my like kitchen table is the cafe instead of going to my office.
Yeah. So you like change locations within your house.
Yeah. Yes. Yeah. Mm-hmm. But that works well for me because I have no children that live in my house. Yeah.
You could do, if you ever just want an extra change, the co-working space, which I may bleep the name out of earlier and remove it.
May or may not.
Is they have this punch card thing.
Yeah, I've
you
heard
can
of
just
that.
buy a punch card. You could come work near Ryan and I any day you want to, or wait till we're not there and go work there. But it's cool because it's just like you have this punch card. You can use it whenever you want to. Instead of feeling like, oh, I've paid an amount, I need to like you be there a lot this whole month. Wherever it's like you've banked some
days.
Yeah.
Cool. That's really cool.
Yeah. So
all right. Awesome. Well, thanks for telling me about that. Maybe I will do that. And thanks for learning about the Northern Lights.
And thanks for teaching me. And thanks, Abby, for asking that question all those years ago. And if you have a question, idea, thought, curiosity, wondering if something is chemistry, please let us know. Reach out to us on our website at chemforyourlife.com. That's chemforyourlife.com to share your thoughts and ideas and questions. If you'd like to help us keep our show going and contribute to cover the cost of making it, you can join our super cool Chem community of patrons on patreon.com/chemforyourlife to help keep our show going and help keep our show free and all that stuff. We'd love to have your help doing that. We have a super cool community over there and some perks to thank you for supporting the show. If you're not able to do that, you can still help us by subscribing on your favorite podcast app, rating and writing a review on Apple Podcasts. I think you can also rate and write reviews for podcasts on Spotify now. I heard somewhere.
Oh, that's cool.
Not confirmed, but I heard that. So you can rate it on either place, review it over on either place, and also subscribe on our YouTube channel and leave us a comment saying that you're there and that you're watching, and that helps us to share chemistry with even more people.
Awesome. This episode was made possible by our financial supporters on Patreon, and it seriously means so much to us that you all want to help make chemistry happen, chemistry for your life happen, and make chemistry more accessible for more people. And so I want to give an extra special thanks to those people. We want to. Those people are John T., Avishai B., Bri M., Brian K., Carol R., Chris and Claire S., Chelsea B., Derek L., Elizabeth P., Emerson W., Hunter R., Jacob T., Kristina G., Katrina H., Letila S., Len S., Melissa P., Nicole C., Rachel R., Sarah M., Stephen B., Shadow, Suzanne P., Timothy P., Venus R., Radioactive Dreams, Cullyn R., and Jeannette N. Thank you all so much for everything that you do to make Chemistry for Your Life happen. And an extra special thanks to Bri, who often creates illustrations to go with episodes of Chemistry for Your Life that you can see over on our YouTube channel. And you can thank Bri by following her and supporting her at Bri McAllister, at McAllister Bri on Twitter, or you can find her website in our show notes.
And if you'd like to learn more information about this episode, you can check the references in our show notes or in the description of the video. Yay, chemistry!
Yay, chemistry! Yay, Northern Lights! That's on our bucket list to see the Northern Lights.
That'd be so cool.